into sealed system, and I want to cover everything about sealed system, not just, okay, you put a torch here, you take this pipe out, you put that pipe in, you're done. I want to go over the tools, the supplies, why this tool is better than that tool, what would you use this tool for, and then actually I started like, okay, step one, this is the first thing you should do when you go to someone's house and you're doing a sealed system job. This is the second thing you should do. I'm taking pictures, I'm doing descriptions, and that's what tonight's class is about. If you look here, steps to sealed system, this picture is David, one of my former students, doing a sealed system job in a refrigerator, and I'll go over that just a minute because it's pretty interesting, some of the things that we did there. Steps to a sealed system repair. If we go over this bulleted list here, before beginning the job, check your tools, supplies, and parts. I had one of my guys just the other day, a former student, had a sealed system job, and about 10:15 he's back at the office, and he's like, man, I need an ultraviolet light. I need an ultraviolet light. Some of these dryer filters have this dye inside of them, and if your refrigerant is leaking or your sealed system is leaking refrigerant, the dye that's inside the dryer filter would leak, and with a UV light it'll show up like a green fluorescent color or something like that. But here he is, he knew he had ordered these parts, now he's going back to do the job and he didn't have the tool, and he's all upset and he's in a hurry, and now he's back at the office looking. I had bought a bunch and gave them out to the techs, and I guess we didn't have any more left. But before you start doing a sealed system job, check your tools, check your supplies, check your parts. Make sure you have everything you need. Next thing is when you get to someone's house, prepare your service area before bringing the tools and parts. I'm sure Chris does when he does his installation, goes in and looks, what job am I going to do? How much room do I have? Do I have to move stuff out of the way before I take a hand truck and roll something in? The same thing when you're doing a sealed system job. You have a lot of tools that you're going to use to do this job, and you need some space and an area. So before you even do that job, make sure you have that space and area to do it. The next thing you do is you're going to start adding service valves and bringing in the recovery tools and equipment. So you're going to go ahead and get the recovery tools and equipment first, like you see in the bottom left-hand side here, recovery tank, gauges, recovery machine, and access valves. Bring those tools in first. Hook up your valves, start pulling a vacuum on it, and recovering that refrigerant into the tank. And while it's recovering, then you go back and get the rest of your stuff. Don't sit there and just keep bringing everything in and bringing everything in. Get a process started where recovery takes a few minutes. Let the machine run, go back and get the rest of the stuff. Sealed system jobs take an average of 1.5 hours to 2.5 hours, depending on how big of a job it is. So if you can organize your time, you can do a more efficient job. Add your valves, connect recovery equipment. While the machine is running, bring the rest of the sealed system tools and parts in. When the recoveries are finished, remove the compressor and dryer filter, okay? And again, that's what if you might just be doing a sealed system job, change a dryer filter, but remove the parts you need to remove. Install the new parts. The next thing you want to do, a lot of people make the mistake after they put a compressor or other components in the sealed system, is they take a vacuum and they hook up a vacuum on it to see if it's leaking, like the braze joints or something's leaking. That's one of the last things you want to do, is pull a vacuum on a system you just put together with a torch. If you're doing a sealed system job and one of your brazes is leaking, if you hook up a vacuum, it'll not find the leak, but it'll tell you it has a leak because it's not pulling a proper vacuum. The problem is while the vacuum's running, you're sucking air and moisture from outside into your system. And the last thing we want to do is contaminate our system. We don't want air and moisture in our system, and that's why we're pulling a vacuum on it in the first place. So what we do is we take nitrogen and we pressurize the system after we put it together with a torch and make sure that it doesn't leak by pressure leaking out. And then if it doesn't hold the pressure, we usually put about 100 psi inside there. We don't want to go too much higher because the evaporator's aluminum and it can't hold it. But we put about 100 psi of nitrogen, and then we close our gauges, and we wait and see if the gauges are dropping. If they're dropping, that means we have a leak, and it's probably one of the braze joints we did. So then we use a soap solution, and we check it for leaks. If we were doing a vacuum pump and it told us we had a leak, you definitely don't want to put soap on any of the braze joints, because what's it going to do? It's going to suck that soap into your system. So that's definitely a no-no. Once you put in nitrogen and you prove that it held the pressure and it's good, then you can let that nitrogen purge it out into the air and let it go. It's free, it's safe. Now you want to connect your vacuum, and you want to start pulling the vacuum down on the system. And you want to use a Micron gauge to pull down to something called 500 microns. When you guys get into the sealed system part of it, you'll use something called a Micron gauge. It's usually a digital tool, and I'll show it to you on the tools page. And that will tell you it's pulling a vacuum. While that is pulling a vacuum, now take your recovery equipment and go put them away. Down here, you got your recovery tank, your recovery machine, and probably other things that you use just for the purpose of recovery. While you're pulling a vacuum, it's going to take 5 or 10 minutes to do. Go ahead and put all those tools away, and then connect the wires for your compressor and the condenser fan or anything else that you need to install while the vacuum is running. Again, conserving your time. While the pump is running, do the other jobs that you need to do. Then you're going to charge it with refrigerant, and then you're going to seal the unit up and remove the valves. You are not supposed to leave access valves on a system after you service it. Now in the class, I'll let you leave it on for the purpose of coming back the next day or two and see how the pressures are doing and doing the job. But when you're done, you want to go ahead and just remove those valves, because those valves will tend to leak. And I'm going to show you some different types of valves and when we use certain valves over other valves and why we use them. Now real quick about this picture, and I just want to show you something here. This is the old Electrolux refrigerator, and this piece right here is part of the evaporator. And it's been taken apart, put together so many times that someone sprung a leak in one of the pipes there, so I got a new one of them, and he's taken it out to install it. But the liner of this refrigerator is all plastic, and this guy's using a hot torch. That heat would normally rise up and melt the ceiling of the refrigerator. So I was trying to think, man, what am I going to do to protect this refrigerator? And I got an idea. I got some real heavy duty aluminum foil, not the cheap thin stuff, some heavy duty stuff. And first I took a big sheet out and I balled it up, and then I straightened it back out. And if you look closely on this picture, I'll try to get even bigger if you can see it. There's 2 layers of aluminum foil here. There's a layer at the top here which is all crinkled, and then I took a second layer and I sagged it down to create an air gap between these layers. And we used aluminum duct tape, the metal duct tape, not the rubberized duct tape. And so this aluminum hanging down and this crumpled aluminum in between and another piece at the top, we had no problem with using a torch and being there for a few minutes without any heat melting. Now, it doesn't really look at it too close, but he's blowing the heat away from that light bulb and away from the back wall of the fridge, sort of towards the opening. It's just the way the picture was taken. It doesn't look that way in the picture. But you can braze inside of a refrigerator, but you have to be careful because you don't want to melt or damage anything plastic within a customer's refrigerator or in the back of their unit. And I got some pictures I want to show you. So that was just a job that he did in the class. Now, sealed system repair tools. Here's a whole bunch of tools. The one thing I didn't put down here, and I do want to add it, I thought of it just as we're talking, is a tubing bender. We don't really need it that often because usually when we're placing a compressor or doing some other jobs, very rarely do you need to add tubing. You're just disconnecting and reconnecting those lines. But a tubing bender is a tool that needed to be added to the list. There's two types of torches that you could have. And if you look up here in the top, we have a turbo torch kit. And then we have what we call an Oxy Acetylene Torch. Now that's a cutting tip. That's not the brazing tip. But you could change the tip on that to make it a brazing tip. What's the difference between the two is that this one has a separate tank for oxygen and acetylene, where this turbo torch uses a tank similar to this, which is just straight acetylene. And it gets its air from some openings on the tip. And if you look at this one's two different tips, there's usually three of them, and you have different sizes. Good thing about a turbo torch is it's not as hot, but it's quick lighting, and it gets you in and out of the job. It takes a little bit longer to heat up the pipe than the oxyacetylene, but the good thing about it is because it's not so hot, it's more forgiving. And what I mean by that is when you're using the oxyacetylene torch, man, that sucker's hot, and you can make a real tiny tip, maybe, a half an inch, quarter of an inch long, where a turbo tip is a little bit bigger and loud and everything else. But when you're lighting the torch, it creates a lot of black soot that can damage customers' carpeting and furniture. And it gets so hot, if you're not careful, you'll burn a hole right through the pipe. And when you do that, you've damaged the pipe. So when you guys are doing the sealed system in the class, I need you to try to use both torches and see which of the two you like, and get used to lighting them, get used to the amount of heat that comes off of them and how to control the heat. The next is the swagging tools and the flaring block. Now these swagging tools right here, this is ones that are used with a ball peen hammer, but you need this flaring block inside this tool set. Now I'll zoom in on that tool set for you. Oops. This tool set here, this has a bunch of different holes for different pipe sizes. You can buy this block separately, and it has the different types of swedges here for the size tubing that you need, and it goes on the end of this device. And these two here are like fingers. They lock into that block, and you have to twist this by hand to swedge the pipe. And swedging makes two pipes of the same size, makes one larger so that it fits inside of another one. This works, but it's very stressful on your hand. You have to really go back and forth a little bit and use it, and it's hard sometimes to expand that pipe and swedge it. So normally I like to use the hammer ones because they do the same job, and with a couple of hits of the hammer, you're done swedging it. So yeah, is this kit good? Do you need one of these kits? No. You do need the block because it's very hard to hold the pipe with your hand and use the swedging tool. The block holds the pipe while you're using these swedging tools right here. So I recommend this. This is only like $10-15 for a set of them. And I put the sizes 1/4, 5/16, 3/8. Those are the sizes you're going to most commonly find in a refrigerator. 5/16 is usually a suction line. 1/4 inch is usually the, 5/16 is the low pressure side, and the 1/4 inch usually high pressure side. The flaring block, again, is this tool. Why do they call it a flaring block? Well, right here above the pointer of the of my mouse pointer, there is a small pointy piece in there. It's called a flaring tool. We don't really flare in refrigeration. You could use it in gas, but again, you buy those fittings. You don't make those fittings. So this is called a flaring and swagging kit. There are cheap ones you can buy for $30-40, and to get the blocks, it doesn't matter what brand they are. The rest of the stuff is sort of, not that great a quality. I really wouldn't use it that much. I would prefer the hammer ones, and a ball peen hammer. And a ball peen just gives a little bit extra more weight when you're hitting down on trying to swedge the tube. Now the next thing is called a flame guard. That's this rag here, and this one here allows a pipe to fit through. And you know, when you're brazing, I don't know how many times, you know, I've told technicians or students, let's say, not technicians, when you're brazing, watch my floor, watch the tubing inside the refrigerator, watch this, watch that. And I could go around the room and show you about 4 or 5 different spots where students were shooting the flame downwards on a pipe while they're trying to braze it. And while they're paying attention to brazing, they're not realizing that that heat is hitting the floor and they're burning the floor while they're doing it. Now, I get a little upset and then it's over with, but in a customer's house, it doesn't roll like that. If you burn a customer's floor, you're responsible for fixing it. And if you work for a company, you know, company's not going to be too happy that you're damaging the customer's floor and not paying attention to what you're doing. Striker, here's a striker. Along with the striker is a set of flints. These little pieces unscrew from right here, and so when you're striking the torch, it makes that spark. It makes that spark when you're using the torch to light it. And these flints wear out over a period of time, so it's good to have a set of these that you always keep on the truck for your lighting a torch. Can you use a lighter? Yes and no. You can use a lighter. The problem is that it's real close to that tip of the torch, and the lighter has gas under pressure in your hand, and your hand's really, really close to that flame. And if that lighter leaks a little bit too much gas, you could burn your hand, or that thing could explode in your hand. Where the striker gives you some distance away from the tip of the torch, it is safer to light the torch with a striker than it is a lighter. Could you use one of those long barbecue ones? Yeah. I would. If you're going to use a lighter, use one of those that put your hand away from the tip of both these torches here. Gauges. You need a set of refrigerant gauges with hoses. I just got finished recording a video Saturday, which I'll post up and send you guys a link on how to use these gauges and how to read these gauges. Vacuum pump. You need a vacuum pump. That's what this is. This one here sucks all the air and moisture out of the refrigerant system so that you can charge it up with Freon. If it has air or moisture in it and that air or moisture mixes with your refrigerant, you can have problems with pressures, you can have restrictions. Water gets in the oil of your compressor, and water and oil are not a good thing. So when you have a refrigerant system, it's very important that you keep that refrigerant system dry. Even when you're cutting the tube, I tell you guys, don't blow on the pipe. It's trivial, but it's just a process. If you just keep that in your mind, look, we have to keep the pipes clean. We have to keep moisture out. We have to, you know, it's just like going to get a doctor to work on you. You know, you don't want to go to a hospital that's dirty. You want to go to a hospital that's clean if you're going to have an operation. You don't want any of that dirt getting inside you. Think of the sealed system the same way. You want to protect that sealed system just like you want to protect the inside of your body. So a vacuum pump is used to pull that air and moisture out. And I added a Micron gauge here under vacuum pump and vacuum. This gauge here tells you how deep your vacuum is. Now, in a refrigerant gauge, I'm going to zoom in on it just so I can show you for a second. If you look right here, there's like this light blue and this green here. And this is 0 pounds of pressure. When you pull a vacuum, this needle starts to pull backwards. And 30 inches, which is this line here, is considered a perfect vacuum. First of all, I've been told there's no such thing as a perfect vacuum. You'll never reach a 30-inch vacuum. A piston is a pump, and when the pump goes down, it pulls that vacuum, but then that pump returns. A little bit of pressure always comes backwards, and it's almost impossible to get a perfect 30-inch vacuum. Now, 29.9 would be something that you would be expected to get when you're pulling a vacuum on a system. So 29.9 is pretty close, but between 29.9 and 30, you can even get a little bit closer to 30. And that's what a micron gauge does. That micron gauge reads in between that 29.9 and that 30-inch vacuum. So we hook that up with the gauges and this pump when we're pulling air out of the system, so we know that we have an airtight system. Now, you could pull a 30-inch vacuum and close the gauge and see that needle sit there. And if your leak, let's say you brazed it, and you have a real small leak, you might not notice it with just a set of gauges. So you go and charge it and tell the customer, okay, ma'am, I'm done. I've charged your refrigerator. That'll be $375, yada, yada, yada. And 2 or 3 months later, a lady calls you back and says, my refrigerator's not cooling. And when you go there, it still has some Freon in it, but it leaked out enough that the refrigerator is not doing its job. Well, a micron gauge, they say when you get this microns, when you first turn it on, it's like 2,000 or 1,500. And as you pull the microns, instead of the numbers going up, the numbers go down. The closer you get to 500 microns is the closer you're going to get to almost a perfect vacuum. And they basically say if you reach 500 microns when you're pulling a vacuum on the system, that system is ready to be serviced and charged with refrigerant. So that is a good tool to have when you're pulling a vacuum here in the system. You need a scale. And here's a refrigerant charging scale. You take your Freon tank and you put it here on the scale. And when you're charging, you can say, okay, my tank is 25 pounds. That's what the scale reads. That's tank and Freon. But as you charge the refrigerator is going to say, oh, I need 6 ounces of Freon. So what we do is we press a button on this little pad here, and we tell it to say 0. Even though it's 25 pounds of Freon, we zero the scale so it reads 0. And what happens is as the Freon is leaving the tank and going into the refrigerator, it starts counting minus, like minus 1 ounce, minus 2 ounce, minus 3 ounce. And if it says put 6 ounces in the refrigerator, when it says minus 6, you close the handle on your gauge and your refrigerator's charged. Because 6 ounces left that tank. Where did it go? Into the refrigerator. So putting a scale is one way to measure that refrigerant. Now, the other reason why you need a scale is when you're recovering Freon, as the tank starts to fill up, you're only allowed to put about 80% of that charge back in the tank. You can't fill it up 100% because if you put it in your truck, the heat will create excessive pressure and that Freon wants to expand. So 80% is liquid, the other 20% is vapor, but it leaves room for that tank to expand. So there is something on the top of the tank called tare weight, T-A-R-E, and tells you the weight of the tank when it's empty. So let's say the tare weight is 12 pounds, and this is it looks like a 25-pound tank. So a 80% of 25 would be how much? Does anybody know? So 8 times 20 would be 16, and 8 times 5 is 40, so 20 pounds. So if you put 20 pounds of Freon in here, you'd be at 80% out of the 25-pound tank. But you wouldn't want to read 20 pounds on the scale. It would be 20 pounds of Freon plus the tare weight, which would be 12 pounds or whatever I said it was. So when this thing read 32, I couldn't put no more Freon in this tank. So a scale is used to prevent overfilling of this tank. Now, I'm going over the tools, and I may be going a little fast, but the idea is to point out these are all the tools you need. The slides that I'm going to put together and the parts that I'm going to put together is not just the tools you need, but then I'm going to break down each tool, how to use it, how to hook it up, where to use it, what do the buttons do, how do I read it, how do I use it properly. This is more of, people say, can you tell me all the tools I need to do a sealed system? That's what this page is for. This page isn't to say, okay, here's the tool, this is how you use it, this is how you adjust it. That's not what I'm talking about in this screen. This screen is just to tell you what tools you need if you're going to do sealed system repair. Okay? Tubing cutter. Here's two different types of tubing cutters. One for smaller tubing, one for larger tubing. Depending on the space you're in, they make a real small one that makes it easier to cut tubing in a small confined space if you had to cut the tube. Recovery machine, recovery thing with a cap tube cutter or file. This is a cap tube cutter. It looks like a wire stripper, but the capillary tube and refrigerant system, you can cut it with this or a triangular file. Either one of these will be used to cut the capillary tube. And when you guys are doing sealed system, I want you to learn to use both tools and see the advantages and disadvantages of both those tools. Just like the swedging, I want you to swedge with both of them and see which ones you like better. A reamer. I don't have a picture of a reamer, but on the end of this cutting tool right here, you see this little black curved line right there. That piece pulled out like a switchblade knife, and that's used to trim off the rough edges of a tube when you cut the tubing. And a reamer sort of like smooths it all out. Now we got spare torch tips, torch tip cleaner. You want to have some extra torch tips in case any of them get damaged, and a tip cleaner, which is just like a little brush or a little tiny pointy, it almost looks like these files that goes inside of the tip of the torch that you can use to clean it out in case carbon builds up or you actually touch the tip of the torch against solder or something. If it gets damaged, you always want to have some spare tips. And you got a hole right in this little box here. This is where you can keep some of your tips and your striker when you're carrying your torch tank right here. Ball peen hammer and then tubing bender. So this is a majority of tools that you need. You can always find a few extras here and there, dial a charge, some other ones. Now, I did not write this down here, I don't think, but these are both types of access valves. Chris, you use some of the ones that you screw on with a little Allen wrench that fits a pipe, and I'll show you in the next slide. But these tools here, they lock right on like you're locking a pair of pliers, and you don't need that tool. This will pierce the pipe, and it'd be 1, 2, 3, and you got access to it. We have that tool in class, and I'll show you that tool when we get back to school on Friday if you come in on Friday. Anybody got any questions about the tools before I go to the next slide?
So, Richard, it's like another set of access tool, like access valve?
Yes, these are the same as access valves that you screw on. These are two different types. They do the same thing. And if you're going to go to a system and you need to hook up your gauges, this tool just snaps right on the pipe. The bottom half, you see, has like a little curve to hold the pipe, and then the top half pinches a hole. And the same with this one. The bottom half holds the pipe, and the top one pinches a hole. They only work good on some tubing. You would not want to do this on what they call steel tubing, like the condenser of a refrigerator. Steel tubing, you can't really pierce it too well. This is good for copper tubing only. Again, we don't leave valves on, so these valves are perfect when you first go up to a system and you have to recover the refrigerant from the system. Sealed system supplies. So not only do you need tools, but you need supplies. Sand cloth or emery cloth. You need sandpaper. So when you're going to braze, number one thing before you braze, clean your tubing. You know, an extra 30 seconds or extra 2 minutes of sanding and cleaning your pipe before you braze it means less time brazing it. If you have dirty tubing and you go to braze it, you're going to have a leak. The one spot where there's a little bit of oil or dirt, the solder's not going to stick and it's going to leak. I don't know how many times I've done it and I've seen other people do it. They braze something and they go to charge it up or pressure test it, and they say, oh man, it's leaking. So what do? They just take a torch and hit it again and try to seal it.
Yeah,
and it still leaks. If you do not clean it, it's not going to fix the leak. Yes, Christian, you had a question?
No, I was just gonna say, like, I had an experience like that when me and my dad were doing stuff as simple as just water pipes. There were times we didn't clean it. We cleaned it, but it wasn't well enough, so like it would just leak.
Yeah,
So,
and if you just
I know what you mean.
if you just try to hit it with a torch after it leaked, it's not. If it was dirty on the first braze, it's dirty on the second and third braze. If you try to sand it and then it still leaks, I tell people, you know what? Take that joint, the two pipes where they meet apart, cut it out, get some clean pipe, and start all over again. You're like, oh man, I don't want to do that. I just want to braze this thing, get done. Listen, don't be in a hurry. This right here is very important that you take your time and you do it right, because if you rush it, you're going to spend twice as much time fixing mistakes than you are just doing the job. I remember one guy, he was a supervisor of mine at Brand Smart, and now he works for GE, a friend of mine for years. And he had a sign on the wall that said, if you don't have time to do it right the first time, when are you going to have time to do it over? So don't rush your jobs. Take your time, follow a process, learn a process, and always do it the same way. Because that one time you try to do a shortcut, and now you're upset because you're in a rush and it isn't working, and you need to get out of here because you got other jobs. That's not going to make your life any better if you don't take the time to properly prepare your braze joints and your fittings and clean them properly. Sill flux. Sill flux is here in this tube right here. You can use it on copper to copper fittings. It's really used more on copper to steel fittings because they are two different metals. They take different amounts of heat for the solder to stick to them. A lot of people, when they take the solder and they try to braze the pipe together, they put the torch and then the solder in the middle and the pipe behind it, and they try to melt the solder onto the pipe. And that's not really how you do it, because if the pipe itself is not hot enough, the solder will just touch it and fall to the ground. The pipe itself has to be hot enough that the solder sticks to that pipe and it flows right around it. I always say like a hot knife through butter. If that pipe isn't the right temperature, the solder's not going to flow. So you want to make sure that you clean it, and then use this silver flux here. And what the flux does is it reduces the oxidization of the tubing. What does that mean? As you heat it, air is released from, or oxidizing, like, like when steel rusts, it releases some of that oxidization within the tubing. And that oxidization also acts like a carbon buildup, and it sort of makes your pipe dirty and causes problems with your solder sticking. So adding flux before you braze the joint together will allow the solder to adhere to the tubing better. So when you're going to put a joint together, apply some of the flux on the tubing first and then braze it. So when you guys are practicing in the shop, I want you to braze two pipes together without anything. Don't even clean it. Now clean it with sandpaper and everything, and then try it. Now clean it and do it with flux. Now do that copper to steel. Do the same thing. Practice with the different pipes and the different tools and see what differences it is, so that you say, oh, well, Z always says use flux, but heck, I don't need it, But see what works and how it works for you, so that when you're doing the job for real and you don't have teachers standing next to you, I do this because of this. Okay? Brazing rods, 15 and 45%. Sill floss, or sill foss, I always say floss, 15. That number 15 means it has 15% of silver. And we're talking about the silver you put around your neck. Okay? This is 45% silver. In other words, the metal that makes it up, they mix silver with other alloys that help it flow onto the pipe. The AC class, Mr. Jansen, that used to teach it for years, used 0% silver. Well, that was real hard to get the solder to flow. I always use 15 for you guys because, yeah, I can buy the 5 or 0% solder, and you guys would have a hard time brazing with it. But, I want you guys to learn to do with the good quality stuff, because when you're brazing, you want to have the good quality brazing so that your job is done easier and better. So 15 can be used on everything, but remember I said copper to steel, they're two different metals. And they require different temperatures for the solder to stick to those pipes. So 45% silver will melt and adhere to the pipe at a lower temperature. So we usually use 45 on a copper to steel and a 15 on everything else. And you say, well, copper to steel, what do you mean copper to copper, copper to steel? The condenser, and I'll show you a picture of it, on a refrigerator is usually made of steel tubing. Everything else is usually made of copper. So, when you connect the condenser to the compressor or the condenser to what we call the hot gas loop or whatever, you're using two different metals there. You want to use 45, you want to use flux, you want to sand and clean it, and you want to prepare your service area for that. Excuse me. Refrigerant 134A and R600. Here are the two refrigerants. You can buy R600 in a 30-pound cylinder, but guess what? The government doesn't want you to carry 30-pound cylinders in your truck because this has isobutane in it. Butane, the same thing in your lighters. You do not want to carry a 30-pound cylinder in case it leaks. It becomes flammable and explosive. These are smaller, 1 pound, 2 pound cans, like 18 ounces or something like that. So these are acceptable to carry, but you want to keep them in a protective box or something because they are sort of thin. And we had someone in the shop practicing with one, and it fell to the ground and punctured the tank, and that refrigerant leaked out quite easily. Where these tanks, the steel of these tanks are a little bit more thicker and a little bit stronger, reduce the risk of leaking. Storage of these tanks on your vehicle is very important. You don't want them rolling around. You don't want them where things are going to fall on them or anything else. But a 30-pound cylinder 134A is okay. The smaller 600A is what you would carry on your truck when you're doing work. Vacuum pump oil. That's what this unit is here. Your vacuum pump needs oil and should be changed regularly like a car, especially if you had like a compressor burnout in a system. You don't want bad oil in your pump because it's just going to ruin your pump. On the vacuum pump, and let me see if I can go back to that other page. Vacuum pumps have on the very front of them, I'll move it so you can see it, a little sight glass on the front. And there's a line going across that says oil level. Before you use a vacuum pump, you always want to check its oil level and make sure that it's properly filled. And also that the oil looks clear and clean. That oil, you can see the oil in there. And if that oil looks dirty, brown, sluggish, like a chocolate shake, you need to change that oil. And there's a little screw on the very bottom there for a drain, and there's a plug on the top where you fill it up, and you fill it up to that line. So when using a vacuum pump, always check the oil level, and always keep a bottle of spare oil on your truck. So when you're doing a job, if your pump's a little low, you got that oil there with you to refill it and repair it, refill it or service it. The next thing is spare dryer filters. These are dryer filters. I don't know how many times I've seen guys reschedule a service call because they didn't have a dryer filter on their truck. And I'm like, really? You should carry this on all of all the time. Because if it's just a leak repair or a restriction, and you could just recover the refrigerant, cut a little piece of the capillary tube or something, put a new one of these on, and get the customer running. Remember, we talked in business, one of the things that's going to make you money is the first time completes. So carrying a handful of these dryer filters on your truck, you know, they can be used in almost any brand refrigerator. You could take this from a Frigidaire to a Whirlpool to a GE, and if you're doing a sealed system job, this one will work. Now, if you notice, this one has an access valve on it for the high side pressure already. We're supposed to remove these before we leave the job. A lot of people don't. You know, I understand why. There are sometimes problems when removing valves that sometimes you create a leak after you've done the whole job, and now you got to fix that and start over again. But if you leave it on and then they leak later, then the customer's calling you back and those valves leaked. Under warranty, the manufacturer wants you to remove them. If you left the valves on after doing a warranty job, a lot of manufacturers might just pull away your warranty authorization knowing that you left the valves on because they want you to remove them. And I've been told by some of them directly, don't leave valves on a system. So you want to keep access valves. Now, I do have some pictures of the bolt-on access valves, and I showed you the two with the pliers in the other picture. But if you look at these here, these are called stem valves. These are the same valve that's like on the dryer filter. And I will show you guys in class. What I like to do is like to take about a foot and a half of pipe and solder it to the end of this valve. And when I put it on the compressor, I can cut and pinch the pipe off and remove it and reuse these valves over and over again. If I had this many valves on my truck right now, I could go 5 years with those valves and service many, many refrigerators without having to buy any more. You know, nothing gets me a little upset when my tech says, oh, I need to buy more valves. Well, where are all your valves? Oh, you're leaving them on refrigerators and you're leaving money there. If you can reuse these valves, and there's nothing wrong with reusing them, then why leave them on a refrigerator and buy more? Oh, well, I'll just charge the customer an extra $10 for valves, and then I'll just replace them. Okay, it's your decision. I recommend that you don't leave the valves on the system. Valve core removal tool. Inside of these valves, there's a little core. Now, this little picture here is hard to see. That's a core that screws inside of the valve. This is the same thing that's like in a bicycle or car tire. When you hook the hose on, it pushes on this little spring. I know the picture's not that clear, but it allows you to take the hose off and leave the pressure in the system. When I use these valves and reuse them, I'll answer your question in a second, Imran. When I reuse these valves, or I use them to charge up a system or something like that, I don't even leave these cores in there. I take the cores out. I never use those cores because they're inside that valve and they slow down the vacuum process, the recovery process, and the charging process because they have to go through that pipe with that core in the way. Now, the question about leaks, and that's why I was saying, is like a lot of guys leave the valves on there because that's another tool that I didn't add was the pinch-off tool. So that reminds me, I got to add that to the list. There's a pinch-off tool which looks like these vice grips here, these right here, and I'll go ahead and I'll look it up right now. The pinch-off tool squeezes the pipe and it seals it so you can use a torch to braze it. And sometimes the pinch doesn't work too well. I'm going to go ahead and show you guys here. The pinch-off tool right here, if you look, it has no teeth on it. So when you bite the pipe, and here's a picture of it biting the pipe, it pinches the pipe. But here's the problem. If you look at the tool is at an angle. It's closer together here than it is there. So sometimes when you pinch it, right on the very end here, it doesn't seal it. So what I always tell people in the class is use 2 of these. And when you use two of these, you put one and put in like a 1/4 inch away, you pinch the other one, and you leave them on when you're sealing it up, because they like one end is the valve here and the other end's going to the refrigerator. You pinch them off, and then you seal up the end of this pipe right here, and then you can remove these tools and it shouldn't leak. But again, it's something you need to practice, because if you don't do it right, it will leak. Now, I want to show you in these pictures, this is another type of pinch off tool. It gets the pipe in here and you twist it by hand and it pinches up. I like this one. It works pretty good, but it only does different sizes. This one's $43. You can find it a lot less expensive, maybe $15-20 someplace else. Here's another pinch off tool. It's a Swedging Block, and the center is a pinch off tool. The only thing is you have to twist these by hand, and sometimes it's hard to twist the pipe and get it pinched off real well with this by hand. So people use pliers on these to tighten it down real good, and these little wings on this wing nut here tend to break. So pinch off tools are very important to remove your access valves, and I'll add them to this sheet here, but that's a tool that you need to have. Going back to the supplies, copper tubing. You don't need big rolls of copper tubing, but I would say 2 or 3 feet of 1/4 inch, 5/16 and 3/8 tubing is good to have. Sometimes pipe is damaged, or you're changing a compressor and it's not like the original one. Sometimes the compressors come with a little bit of extra tubing so you can extend the tube. And in practicing in the class, I have you guys redo some of the tubing underneath there. So you practice replacing and editing the tubing to learn what you can do and how you can service those tools in there. Heat shield or spray gel. This is a heat shield, and it is not perfectly flame proof, but it does reflect the heat. And you have to be careful, because the idea is not to damage something that's behind it, but they will burn up. And I've seen guys take and put water on it. Really doesn't help. It just becomes a mess, and you're getting water now around all your braze joints and everything. Just get in there and use the heat shield, but try not to use the heat shield where you're blowing your flame right on top of the shield. The heat shield is more to reflect the heat itself and not so much the flame. Now, if you have no other choice but to shoot your flame in the direction of that, then do it. But they have these two things here, thermal trap and cool gel. We have both of these in the class. And what those do is those help reduce heat expanding from the tubing and everything else to prevent from burning or causing any damage when you're using a torch and you're brazing. So that's some of the supplies that you need right here. All of this stuff is what you need to carry in your truck. All these tools here you need to carry in your truck, plus those pinch off pliers. And I say 2 pairs of pinch off pliers, not 1. Step 2, servicing a refrigerator. This is actually my apartment. I went ahead and pulled my fridge out, cleaned up behind it. You know, when arriving to customer's homes, first check the area to be serviced. You know, like this picture here, make sure that there's nothing around here. But before you pull it out, check the floor, check the cabinets. I spelled the word around wrong. Check any area before you actually service it. If there's damage on the customer's cabinet, take pictures and tell them, say, ma'am, listen, I'm getting ready to pull the fridge up, and I notice this corner of your cabinet here is a little bit damaged. You know, it might have been damaged for years. They never knew it. But once you pull the fridge out, put the fridge back, that's all they see. And they're going to say you did it. No, that was there before. Inspect the area before you service it. Okay? Take pictures. Check the water's turned off behind the fridge. Look at the way they twisted that. Copper tubing or lead tubing, make sure you turn off the water, unplug the refrigerator from the wall, move this thing out in an open area where you can get behind it. Verify the problem before doing the job, especially if another technician ordered the parts. Nothing is more frustrating than going to a job like this and changing a compressor, which is an 1.5 hour long job, and the new compressor is not working. and you're like mad thinking, oh, the new compressor might be bad. The guy before you might have misdiagnosed it. It happens. We're all human. We make mistakes. But let's just check it out before you do this whole job and confirm, yeah, the compressor's bad. I got power to it and it's not running. I'm going to replace the compressor. You know, don't do all that labor. Find out it didn't fix the problem. And now you got to go back and do everything all over again. Unplug the refrigerator. Remove the rear access cover. This cover here. Remove this. Make sure pipes and condenser are clean. Remove any dirt and debris before starting. Dirt will get into your sealed system and may cause other problems. So when I pulled it off, I noticed, damn, my condenser's a little dirty. My vacuum's at my shop, so I got to clean it out. And there's some dirt down here. Clean this area out. Don't just start working on it with all this dirt here. Clean it out so that when you're ready to do a job or put it back together again, this dirt doesn't get on your pipes or in your pipes. So this is going to the condenser. This is high pressure. This is your suction line coming from your evaporator. I'm sorry, this is your high side line. This line here is your process stub. It's not connected to anything. I got some close-up pictures of it. I'll talk to you about it in a minute. But let's read this. No, once rear cover off, check your service area. Condenser fan needs to be clean. Condenser and fan needs to be clean. I got to re-edit. If it's not so dirty, it really drastically affects the cooling, but helps. It does. Man, I don't know what I was thinking when I wrote it. It is not so dirty. It does not drastically affect the cooling if it's that dirty. If it's super dirty, yes. But this little bit of dirt really doesn't make that much of a difference, but keep it clean because this should be done regularly. If you're doing a job, you tell the customer, man, while I'm here, I'm going to clean this all out and I'm going to do this job for you. The condenser, fan, wiring, and water lines inside this area are all made of plastic. In order to change this compressor, this line right here, and I'll show you close-ups of it, and this line right here need to be taken apart. And they're usually taken apart with a torch. When you heat them up, look at all the plastic parts here. Where are you going to put the torch that you're not going to damage any of these parts? If you have to, take the condenser fan and this, what we call the shroud, away and remove it. It's going to give you more room to work and less chance of ruining it. Well, I think we have one refrigerator in the class where a guy was using it and melted the blade of the fan because he wasn't paying attention. Down here is a drain pan. When the unit goes into defrost, the water drips into this pan and the heat from the condenser and the fan evaporate that water. Well, if you put too much heat and you melt the pan, every time it goes to defrost, now it's going to leak water on the floor. So you have to watch these things as you're using the torch. Okay, I've had guys taking the torch and they're saying, well, I'm not going to put my torch facing towards this plastic relay here. I'm going to have the torch facing this way and facing down. They're sitting there watching this pipe, and they got a pair of pliers holding the pipe. Another hand is holding the torch, and they want to pull this pipe out. In the meantime, they're burning the floor, and they don't realize it because they're not watching what they're doing. So I'm just telling you guys, as you're doing your brazing, you need to be aware of that so you don't damage the customer's floor. The next thing are these different valves, and these are the different types. These are bullet valves. All these valves are temporary and should only be really used not to charge the system with Freon, but to recover the Freon, to take the Freon out so you can open this up for service. We have different types of bullet valves here, and we got these different piercing valves. These are good. The only bad thing about them is that if you use them over and over again, I don't know if this one I can zoom in so you can see it better. You can see the slight point right there. That's what pierces the pipe. And if you use it too many times, it becomes dull or it could become bent if it does not work properly. And the thing is that once it doesn't pierce the pipe, the tool's no good. Now, they do sell replacement tips for this. But, again, have a couple of these extra cheap ones on your truck. You can use this if you want, but for some reason, if it's not piercing the tube properly, you got this as a backup. And again, all of these can be reused. Now, this has a rubber seal and that has a rubber seal. We have to be careful that they're not damaged because once we pierce it, if that seal does not seal the pipe properly, the Freon's just going to leak out and we can't recover it now. And on this unit at the top, we don't see it here, but there is a seal here when you pierce it onto the pipe so that it does not leak Freon when you go to pierce the valve. Now here's a close-up of it. Look at your plastic fan and shroud are right here, and if you're using a torch to take this joint apart, you got to be careful of the fan. The fan's running, it's a little hard to see the blade, but you got wiring behind here, and you got rubber down here, the grommets. So anywhere you put that torch, you could damage wiring, plastic, rubber, and burn something. So you really have to say, well, how the heck am I going to get my torch in there, and how am I going to braze it? Well, one of the things people do is they go ahead and they just remove this whole fan and shroud out of the way. Now you got room to get your torch in here. Okay? Now this is the process stub. It's a little hard to see, but the pipe ends right there. And the factory sealed it off with a torch after they were done. And this is the pipe the factory uses to charge the refrigerator. This is where you would put your access valve to recover Freon and to service the low side of the system to check for pressures and everything else. If I'm going to put a temporary valve on there, I put the valve on the far end right here, because if I can check pressures and see that the pressures are good, I can pinch the pipe right here, cut that valve off, and solder it on the end here, and I still have some extra pipe left over. If I put the valve right here, if I take the valve off, now I got a hole in the pipe right here, and it's really close to this braze joint. There's not much I can do to seal that up once I put a hole like right here next to this braze joint. So where you do it and how you put the valve is very important. Also, if you look at these, look at the angle at which this threaded portion is and the angle at which this threaded portion is. And here, if I take the cap off, it's threaded, and here, take the cap off, it's threaded. When you mount any one of these onto the pipe, before you just pierce the pipe, you got to say, how am I going to connect the hose to it? Because if I put a valve right here, but the threads are facing the fan, and I'm on this side of it, I can't get the hose connected. I want the piece facing out so I can connect my hoses to it so I can service it. So this is one of the stubs or the process stub that you would service it to get the low side pressure. Now we can completely service this side of the system with just a low side access valve. But if we have a restriction, it's going to be difficult to properly recover, evacuate, and charge the system. So a low side valve works, but in some cases you might need to have to access both the low and the high side to service it. In the next picture here, this is the other side of the compressor. The Freon is flowing from the top down through this dryer filter into the capillary tube here. But I pointed out plastic things, the plastic roller here, the wiring and the relay and capacitor and overload. And right here there's a tube, and you can see it's pinched off right here. They use a pneumatic pinching tool. They don't even braze it. They just pinch it so tight that it doesn't leak. They use like a pneumatic tool. It's too expensive for us to have something like that, so that's why we want to pinch it with our pliers, use a torch to seal it. Now this is like that dryer filter I showed you that had an access valve on it. It's been removed. Some of them don't have this secondary pipe. So if you had to connect a valve, you would connect the valve on this short stub right here. So if you're going to recover Freon, you're going to remove this anyways. You're going to take a torch and remove this pipe here because you got to replace the dryer filter whenever you do a sealed system job. So we also have to be careful because look at this. This is foam that they use in the wall as insulation. And this is like putty here, but it has foam. So all that heat's going to rise up here. And if you're using a torch in here, even though the wiring's down here and heat rises, it will melt the insulation inside this box if you're not careful. So adding access valves, installing them a certain way, and picking where you're going to do all these tests are very important. And then also surveying the area before I put my torch. How am I going to approach this, and how am I going to prevent any problem? You could take that flame cloth and lay it over top of all of this while you're brazing here and the capillary tube, and you could protect it. But if I don't want to use the torch right here, but if I disconnect this joint right here, I could take pliers and grab this dryer filter and pull it out. The capillary tube is usually quite long. It actually runs up behind here and behind this arrow and wraps around up here in the top. So you could pull it out of the enclosure of the compressor and take a torch and remove this part of the capillary tube outside of the unit. You only need to use the torch one time. When you're changing the compressor, notice I told you want to put a torch here. This suction line's pretty long. And if I go back to one more picture, let me see some. I had one picture. Well, I guess you didn't see the whole thing. But this suction line goes here and goes like this and comes around this way. If I unbolt the compressor, I could pull this compressor out and take a torch and remove that pipe while it's outside of the compressor area. I don't need to add heat while it's in there. But on the on the low side, this pipe might not give me enough length to pull the compressor out of this area to use a torch in this area. So, what I plan on doing, this is as far as I got with putting all this material together, and I want to get a little bit further. What I plan on doing is actually having pictures and videos and actually doing live demonstrations on how to do some of these jobs, as well as you guys doing some of these. This is going to be like a multi-part series of tools, servicing tips, how to do them, and then each page after this is going to break down, okay, you're going to connect this valve here and this valve here, and now we're going to talk about the valves a little bit more in detail. Then we're going to do the recovery, and we'll talk about the recovery in detail. What is the machine doing? How is it actually recovering? What is it actually doing? So this thing with these steps is not only steps on what do I do first, what do I do second, what do I do third when I'm doing this kind of job, but also what is the tool actually doing? I know it's recovering, it's taking the Freon out, putting it in the tank, but how does it work? What is it doing? So this is going to be a multi-part of a series of videos that I'm going to put together and create one giant video on how to do the whole job, but with more detail and more explanation. I think I've gone the hour in the class already. Do any of you guys have any questions about anything that we've discussed?
When you're recovering, how long does it take usually to recover the Freon from a split system when it comes to the AC system? Not AC necessarily like a refrigerator.
Oh, well, the refrigerator only has about 3 to 6 ounces of Freon. And recovering refrigerant, especially if you're accessing both the high and the low side, that will only take you a matter of 10, 15 minutes at the most. If you're doing a central air, you could have pounds of Freon in there depending on the refrigerant size. And again, the nice thing about central air is they have access valves on them already. You're not adding valves. And you can recover from both the high and the low side at the same time. But the system is much larger. One of the things that's going to affect your recovery time is going to be the amount of refrigerant. Now, real quick, and then I know Chris got a question. Vacuum pumps are important as far as pulling a vacuum on a system. They are rated on CFM, which is cubic feet per minute. And I mean, when I was doing this, I have like in the class like a 2 or 3 or 4 CFM vacuum pump. Now I went to buy one of my techs a vacuum pump, and Johnstone Supply, where I buy my pumps from, says, no, all we got are 6 CFMs. Well, there's no such thing as over-evacuating. You could sit there and run a vacuum pump for 30 minutes, or you can run it for 2 hours. You're not going to hurt the system. But the higher the CFM, the higher the cubic feet per minute, the faster it's going to pull a vacuum. Go ahead, Chris. What's your question?
Yeah, on the overheating thing, I thought that cooling gel pretty much would solve the problems of melting something you didn't want. And why didn't you use it instead of that aluminum foil on that first example?
Well, back then when we did it, I was not aware of cool gel. And I'm going to be honest with you, the size or the area that is plastic on that unit, it would require a lot of cool gel or cool gel spray or heat block spray. I felt more comfortable with the aluminum foil, and like I said, I had to come up with another way to protect the plastic because I didn't know about cool gel at the time. So I don't know how well it would work and how much of it would you have to use and how big of an area would you have to use it, because if you're inside and that heat's rising up to the roof, that heat not only goes to the roof, but now it's traveling across the roof and going down the back wall and probably melting that light bulb that was in the back there or something like that. So again, it works, and I had to figure out a way to do it without the cool gel or the heat shield at that time. I wanted to say, is there another way? And aluminum foil is not that expensive, and a couple pieces of aluminum foil tape, and it worked just fine. We pulled that tape off, and we touched the ceiling after we completely removed the evaporator and brazed in a new one, and it was just slightly warm. I mean, just lukewarm, almost like it's been sitting in the sun. It wasn't hot at all. So,
Okay.
any other questions, guys? No? Okay, so tomorrow night I'm going to add some more parts to this. I'm going to post this up on the TMM channel, so if anybody wants to see it later, that they're welcome to go to that channel and watch it.